Hi, in this lecture we will cover relational and logical operators. Let us first see relational operators. Relational operators are also binary operators, which means these work on two operands and the result is either true or false. So we have a greater than operator, which means if OPR1 is greater than OPR2, return true, otherwise false. We have greater than or equals to operator, which means if OPR1 is greater than or equals to OPR2, return true, otherwise false. Less than operator, if OPR1 is less than OPR2, return true, otherwise false. Less than or equals to operator, if OPR1 is less than or equals to OPR2, return true, otherwise false. Double equals operator, if OPR1 double equals to OPR2, return true, otherwise false. Note that single equals sign represent assignment operator. So if we write OPR1 equals to OPR2, this means assign the value of OPR2 to OPR1, or we can also say that copy the value of OPR2 in the memory location of OPR1. We will see assignment operators later. But to check if two primitives are equal, we have double equals operator. Not equals operator, if OPR1 not equals to OPR2, return true, otherwise false. Let us see an example of relational operators. In this example, we are using 8 variables. First one is byte type, name is B1, value is 5. Then we have short type, its name is S1, value is 5. Then we have integer type, its name is I1, value is 5. Then we have another integer variable, its name is I2, value is 10. We have a long variable, name is L1, value is 5. Then we have a float variable, its name is F1 and the value is 5.0. We have a double variable, name is D1, value again is 5.0. Finally, we have a char variable, its name is C1 and the value is 5. Note that the char can store numbers from 0 to 65535. Now let us predict the output of these statements. So this first statement, say B1 equals to S1, B1 is 5 equals to 5. Is 5 equals to 5? Yes, so this will return true. Second statement, I1 equals to L1. So I1 is 5, L1 is also 5, equals to 5. Is 5 equals to 5? Yes, it's true. Note, in this case, we have compared byte to short, and in this case, we have compared int to long. But if the values are same, we will get true. Now in this case, I am comparing an integer value to a float value. So what we are doing over here, 5 equals to 5.0. What do you think? What should be the output? Because the value 5 is equals to 5, which will return true. Similarly, over here, I1, which is 5, equals to D1. D1 is 5.0. This expression will also return true. Then we are comparing float to double. Float value is F1 is 5.0. D1 is also 5.0. Is 5.0 equals to 5.0? Yes, true. Now we are comparing integer to character. Integer is 5. Is 5 equals to C1? The value of C1 is 5. Is 5 equals to 5? Yes. So the first 6 statement will return true. Now let us see last 4 statement. It is saying I1 equals to I2. Is I1, which is 5, equals to 10? No. So this will return false. Over here, is I1 not equals to I2? Is 5 not equals to 10? Yes, 5 is not equals to 10. So this statement is true. Now second last statement, is I1 greater than equals to I2? I1 is 5. Is 5 greater than equals to 10? No, 5 is not greater than or equals to 10. This is false. Now the last statement, I1 5 is less than equals to 10. Is 5 less than or equals to 10? Yes. So 7th and 8th expression will return false and all other are true. Let us now verify this. So over here, first 6 are true, 7th and 9th are false. Let us now see logical operators. Logical operators are also binary operators, which means these work on two operands. Both the operands in this case must yield a Boolean result. We are going to see double ampersand sign, which is known as logical AND, single ampersand, bitwise logical AND, double pipe, logical OR, single pipe, bitwise logical inclusive OR, caret sign or cap sign or hat sign, bitwise logical exclusive OR, and finally ternary operator. This is a bit different from these 5 operators because ternary operator works on 3 operands. Now as these 5 operators work on 2 operands and both the operands must yield a Boolean result, so to get the final result there are some rules for each of the operators, and these rules are known as truth table. Let us first see the truth table for logical AND and bitwise logical AND. Truth table is same for both the operators. If both the operands are true, then the final result will be true. Otherwise, in all other cases, final result is false. Now there is slight difference between double ampersand and single ampersand operator in the way Java runtime evaluates both the operands. Double ampersand operator supports short circuit evaluation. What does this mean? Now consider these two cases. If first operand evaluates to false, whatever be the value of second operand, be it true or false, the final result is always false. So in these two cases, if you use double ampersand operator, Java runtime is not going to evaluate the second operand because the final result is always false. And that is why double ampersand operator is also known as short circuit AND operator. But if we use single ampersand operator, then Java runtime will evaluate both the operands. Let us see an example on this. In this case, we are using 4 variables. First one is A1. It is of char type, character type. The value it stores is A, and A is equivalent to decimal 65. Second variable, which is also of char type, its name is A2 and it stores the value 65. Third one is an integer variable. The name is I1 and it stores the value 5. It is of integer type. Finally, the fourth one is also of integer type. Its name is I2 and it stores the value 10. Now consider this expression. First one says I1 equals to I2. Is 5 equals to 10? No. This is returning me false. Now in this case, because I am using short circuit operator, whatever be the result of this expression, the final result will always be false. So in this case, because we are using short circuit operator, Java runtime will not evaluate this expression. It will not go and check the result of this expression. And this is not short circuit operator, so this is false. I1 equals to I2 false. The Java runtime will still go ahead and evaluate this one. So A1 equals to A2. Is A equals to 65? Yes, the decimal value of A is 65. So 65 equals to 65, which is true, and this will return in false and true equals to false. So the final result is always false, but in the first expression, Java runtime has not evaluated the second expression. Had this expression been written in another form, such as A1 equals to A2 ampersand ampersand I1 equals to I2. So this first expression is true because A equals to 65, the decimal value of character capital A is 65, so this will return true, and to find out the final result, we still need to evaluate the second expression. Whether we are using a short circuit operator or not, we still need to evaluate this expression. So this is I1 equals to I2 will result false because 5 is not equals to 10. So the final result will be false. So in case of logical AND, short circuit operator will come into picture if and only if first operand evaluates to false. Let us check the output. So res1 is false and res2 is also false. Now let us check the truth table for logical OR and bitwise logical inclusive OR. The truth table states if either one of the operand is true, final result will be true. If both the operands are false, final result will be false. Now consider these two cases, first and second. If the first operand is true, whatever be the result of second operand, be it true or false, final result is always true. So the short circuit operator comes into picture in these two cases as well. So if you use double pipe sign, it is a short circuit operator, but if you use single pipe sign, then both the operands will get evaluated to get the final result. Let us see an example on this. So this is the expression A1 equals to A2. Now A1 is 65, A2 is also 65, so this is true. And we are using a short circuit operator, so no need to evaluate second expression. The result will be true. Over here A1 equals to A2, this is true, and because we are not using a short circuit operator, so the Java runtime will still go ahead and evaluate this, which will return into false, but true or false will return into true. In case of logical OR, the short circuit feature will come into picture if and only if the first operand evaluates to true. Had this statement been written in this form, I1 equals to I2, short circuit operator, A1 equals to A2. So this I1 equals to I2. This is 5 equals to 10, which is false. If this is false, to find out the final result, we still need to go ahead and evaluate the second operand. So false or A1 equals to A2, which is true because 65 equals to 65. Final result will be true. So in this case, res3 and res4 will be true. Let us now verify this. Res3 is true and res4 is also true. Let us now check the truth table for bitwise logical exclusive OR. Final result is true if one of the operand is true and another is false. So true, false, true, false, true, true. Final result will be false if both the operands are true or both the operands are false. In this case, there is no short circuit operator. Let us see an example of bitwise logical exclusive OR. Over here, A1 equals to A2. This expression is true, and I1 equals to I2. This expression is false. So first operand is true, second operand is false. The result will be true. In the second one, this will result into true, and I1 not equals to I2. Is 5 not equals to 10? This statement is correct. So this expression is returning true. First operand is returning true, second operand is returning true. So final result will be false. So in this case, res5 variable will have true value and res6 will have false value. Let us verify this. So res5 is true and res6 is false. Let us now see ternary operator. Ternary operator works on three operands. First operand is before the question mark sign. In this case, it is expr1. Second operand is after the question mark sign. In this case, it is expr2. And finally, the third operand is after the colon sign. In this case, it is expr3. expr1 is a Boolean expression or variable whose result must either be true or false. Now, what are expr2 and expr3? If expr1 evaluates to true, then expr2 is the value that is returned. But if expr1 evaluates to false, then expr3 is the value that is returned. Let us understand this in an example. Over here, time equals to 11. This first expression is a Boolean expression because it will either return me a true or false. Now if this first expression is true, this will be the value that will get returned. If this evaluates to false, then this value will be returned. Now let's check the expression at runtime. So time is greater than equals to 12. So at runtime, the expression will be is 11 greater than equals to 12, which is false. So this value will get returned in this case, and S will point to AM string. So if we try to print system.out.println S, it will show as AM. Let us verify this. Over here, S is AM. Now let me change this. Let me change the time to 14 Now at runtime, I'll check is 14 greater than equals to 12, which is true. If the value of the first expression is true, then PM will be returned. So in this case, S will point to PM, and when we execute, PM will be printed. Let us verify this. Right click, run as Java application. S is pointing to PM. With this, we have come to an end. See you in the next lecture. Till then, happy coding.